Hello, and today we're going to learn about Newton's method. The purpose of using Newton's method is to approximate real zeros of a function, and we do this by using tangent lines to approximate the graph of a function as it nears its x-intercepts. A crucial part of learning how to perform Newton's method is memorizing and using this handy-dandy chart that we have here. So in this left column, there's the n value, which will help you keep track of how many iterations you're doing. And the x of n value is basically just the starting value usually, and it will be this value moved over every time you start a new iteration. F of xn is just this value plugged into the function, and then f prime of xn is, you guessed it, the derivative of f of x, but then you plug xn into there. This is just the ratio of these two values, and then here you just subtract this value from the original starting value you have in this column here. Iterations are basically just each successive application of the procedure. So say that you have x here, and then you go through everything and you find that you find c here, then you put c here, go through everything and get d here. This is one iteration. And then actually, since I put d here, this means that there's been two iterations, sorry. Okay, so let's try a problem now. The problem says to approximate zeros of a function until two successive approximations differ by less than 0.001. And then they're giving us this function here. First, what you want to do is set up that chart that we talked about previously. So I'm just going to do that real quick. F prime of xn, f of xn over f prime of xn, and xn minus f of xn over f prime of xn. Just make the nice lines. Make it a little longer. Make the horizontal lines. Yeah. Great. Okay. So let's find the derivative. So the derivative of f of x is 5x to the fourth plus 1. Okay, now that we have our chart set up, we're going to find the starting value by graphing the function into a calculator. Now I've already done that, and based on the graph that has been made by the calculator, I'm just going to kind of estimate a starting value of about 0.7. I'm going to put that here, 0.7, as my xn value. And then I'm going to I'm going to store the function, this function here, and the derivative of the function into little values in the calculator like so. And then I'm just going to plug everything in with the calculator, divide things for this column, and subtract values for this column as best as I can. Okay, so after using my calculator, I got these following values, and then this final value I'm going to move back over into the starting value over here, and then repeat my process until this number and this number and the next number differ by less than 0.001. So after continuing to plug in values and finding values, we finally get the answer here, which is the approximated zero of this function when the two successive approximations differ by less than 0.001, as you can see from this to this. That's our answer.